is a thermochemical process in which surface of machine parts and tools are enriched in nitrogen. In high temperature processes in atmosphere of ammonia, surface diffusion layer of improved tribological, anti-corrosion and wear resistance property is being created. Elements that undergo this process are mostly parts of machines and vehicles, such as crankshafts, gear wheels, camshafts, piston rings, valve discs and nozzles, as well as tools like molds and drills. Created diffusion layer, depending on nitrided potential, can consist of eta gamma prim alpha, and alpha phase. During nitriding processes in high temperatures reaching between 490 and 560 degrees Celsius, ammonia, when in contact with metal surfaces, decomposes into nitrogen and hydrogen. As a result of those reactions, the atmosphere in the furnace consists of ammonia, hydrogen and nitrogen. Other parameters that determine its kinetics of growth of nitrided layer, so its pace of growth and phase structure, are temperature and nitriding potential. Nitriding potential is a quotient of molecular pressure of NH3 and H2. ZeroFlow nitriding technology is a result of lifelong research of thermodynamics and kinetics of nitriding by Professor Leszek Małdziński. Its industrial version, however, is a joint success of teams from Poznań University of Technology and SECO WARWICK from Świebodzin. ZeroFlow is the most advanced and yet most simple in operation controlled gas nitriding method. It relies solely on using ammonia gas throughout the whole process. Flow of ammonia is being periodically reduced to zero, which enables a precise control of nitriding potential and formation of designated layers. Offline Simulator is a computer software based on thermodynamical and kinetic equations, as well as experimental research describing speed of growth and phase structure of nitrided layer and functions of temperature, nitriding potential, and time. Simulator determines values of those parameters that will result in obtaining designated layers. In offline simulator software, there's a possibility of setting process parameters by hand. Simulations results are presented as values of thickness of nitrided layer, as well as graphs showing change of parameters and layer thickness throughout the process's time. Weak spot of offline simulator lays in arbitrarily set values of heat up speed of the retard and pace of nitriding potential reduction that may be different from its real values. These depend on multiple factors such as furnace's heating power, weight and surface of the load, and catalytic activity of retard surface, all of which are hard to determine. Online Simulator is an offline simulator installed in furnace's software that controls nitriding process based on feedback control. It calculates growth of nitrided layer based on real nitriding parameters and adjusts them in such manner as to achieve desired phase structure and thickness of occurring phases. This graph depicts simulation of process with arbitrarily set values of temperature, which for first stage is 490 degrees Celsius and for second stage 550 degrees Celsius. Heat up speed to first stage temperature is 20 degrees Celsius per minute and to the second stage temperature 1.8 degrees Celsius per minute. Nitriding potential in the first stage equals 10 and in the second stage equals 2. Speed of reduction of nitriding potential from the first to second stage value was set to 0.11 per minute. As a result, layer consisted of epsilon and gamma prim with thickness of 9.2 micrometers and diffusion zone of 0.22 millimeters was achieved. Time of process calculated from 450 degrees Celsius, so from the beginning of calculations until acquiring desired layer, was 7 hours. This graph shows a comparison between the simulation mentioned before and a process with lower speed of heating up and potential reduction. Presented on the graph as dotted lines are real values of temperature and nitriding potential. With lower speed of load heat up and slower potential reduction, the growth of diffusive layer is also slower. In order to receive exactly an identical layer, its thickness structure and effective depth, time of second nitriding stage was longer by 50 minutes, and nitriding potential was reduced from 2.0 to 1.85.